Hello everyone and welcome to my video tutorial on Introduction to Computer Programming using Python. This is class 8 of a series, Control Structures Part 2, Loops. The objective today is to learn about the loop control structures in Python. Motivation. Like we saw in the last class, which was the first part of control structures, they are fundamental to any programming language and to the concept of programming and to life itself. It is control structures that gives logical behavior to a computer. Therefore, it is essential for the aspiring computer programmer in any language to understand and master control structures. At the end of a class, participants should be able to describe loop control structure in Python and various operations with them, write Python programs to create while loop control statements, and perform various operations with them. Content. User input, which is actually not a part of control structure. Control structures: loop iteration, for loop, while loop with lists and dictionaries. Now let's look at user input. Getting input from the user is very important, although this topic is not a part of control structures, but it's something that I should have discussed about earlier and I omitted it, so I just decided to put it here for understanding. The topic just gives advice when you are writing input statements. We have been using the input built-in function to receive data throughout the course. However, there are some things we need to know about writing inputs in a better way. One advice is write inputs clearly. For example, if we say name equal to input, please enter your name. See the way it has been written. The colon, after the last colon here, there is a space before the closing quote, so that when this program is running and it is prompting for the user to enter an input, without this space, it's like the point at which your request for name ends is at that same point, this very same point that the user input begins, and it becomes difficult to read. So the better way to write it is make sure there is a space here before the closing quote. You may use strings to build an input message also. For instance, your input message may be very long. We say prompt. If you tell us who you are, we can personalize the messages you see. That's very long. And then you say, what is your first name? Now, this kind of very long inputs, instead of writing everything together and just putting them in the input statement like this, you can build it using a string. So we have a string called prompt, which takes a part of a statement that is very long, and then we continue the prompt using the concatenation plus before the string ends. So we can now say name is equal to input prompt, rather than writing this whole long sentence inside the input BIF. So that's a better way to construct your inputs. Now, if you want to accept numerical inputs, you have to use the int, like the way we have been doing it. So it is assumed that the user knows they have to enter an integer. It's also good to tell the users in the input what kind of data you are expecting. For example, how tall are you in inches? The user should automatically know that this will be a numerical value. You can also say, if you say what is your age, I expect numerical input, or I expect an integer. So you can convert to an integer if a float, a double, or whatever kind of data variable. So let's see an example of user input. So we'll call this input test.py. The program is to test Python input BIF. Writing clear input. We say name is equal to please enter your name. So we can see the space after the colon. prompt, if you tell us who you are, we can personalize the messages you see. We continue. What is your first name? Now take note that the continuation began in a new line, and then there is also a space before the closing quote. And then you use the variable prompt in the input BIF, using int to accept numerical input, something we have been doing. Height equal to input, how tall are you in inches? Convert to integer. Like you have seen here, you can actually use the same variable that you used to enter the input to do the conversion. So height is here, and the same height is here. It does the conversion for you. So if you run the program, this is what it looks like. So now we are in Visual Studio Code to run the program. Input test.py. So just click run. Please enter your name. And that's exactly how the program goes. What is your first name? How tall are you? Very good. Now let's go to loops proper. Recall from the last class we talked about the types of control structures. The previous class was on conditionals. We were talking about if statements. Now this class of today is on loops, stroke iteration, control structures, and statements. And this kind of control structures are used to repeat a statement or a group of statements a certain number of times while a condition is fulfilled. Each conditional statement has a syntax, the right way it is used. In the same way, each loop statement has a syntax, the right way it is used. There are several types of loops in Python. We have been familiar with for loops right from the earlier parts of the class, but today we are going to dwell more on while loops. But again, let's look at for loop a little bit more. For loops take a collection of items and executes a block of code for each item in the collection. The syntax is: for item in collection, execute this statement, continue executing the sequence of indented statements. For the while loop, the loop runs continuously while a certain condition is true. The syntax is: we initialize a condition to begin with, and then we test. While the condition is either true or false, execute a statement or a sequence of statements, continue executing the sequence of indented statements, and update the condition whether it is true or false again. Otherwise you may end up with an infinite loop. We are going to see that in practice. So there are several ways that you can control your while loop. You need to be able to get out of the loop when it is required. So these are the following ways to do that. One way is by counting. The loop ends when a count is completed, so we'll call this a conditional test. You can either count up or count down depending on your application. Sometimes you don't know exactly which way to do it. You try counting up. If it doesn't work, you try counting down. Whichever one works, you adopt that. You can also exit or control a loop by user input. In this case, the loop ends on a certain input. You can control a loop by a flag. When the flag changes state, usually a Boolean value changes state, then the loop is exited. A flag can be either true or false, a 0 or a 1. Another way to control a loop is by using the break statement to exit the loop. Completely get out of the loop unconditionally. So the break helps you to break out of a loop entirely without executing the rest of the code. Any point where the code sees a break, it gets out of the loop. You can also use something called a continuous statement to control a loop. So when your loop is running and it gets to a line that states continue, from that point on it returns to the beginning of the loop without continuing to the end of the loop. In addition, all of the methods that have been listed here can be combined together to control a loop. So let's see examples. The first one is while loop by counting. We call it while test0.py. So we create a variable and call it current number equal to 1. We have initialized the condition we are going to use to count. So we say while current number is less or equal to 5, this is the beginning of our loop. You can see that the while loop ends with a colon as usual. So every line of code that is going to be indented under that is a part of a while loop. So we say print current number. Remember to update the condition. Current number plus equal to 1, which means we are adding 1 to current number every time we run the loop. The first time the loop runs, it will say test whether current number is less or equal to 5. So the first time current number is 1. And because that condition is true, it is going to print current number, print 1, and then it will add 1 to current number. Current number is now 2. So it goes back again to perform the test the second time. The second time current number is 2. Is 2 less or equal to 5? Yes. Print current number again. Increment current number, it becomes 3. Go back to the top. Is 3 less or equal to 5? Yes. In the same way, next time it becomes 4. Is 4 less or equal to 5? Yes. Print 4. Increment, it becomes 5. Final test. Is 5 less or equal to 5? Yes. Print 5. Increment, it becomes 6. And then it come back and finally it is 6 less or equal to 5? No. In that case, it will break out of the loop. You will no longer print current number and there will no longer be an increment. So the program continues from there. If you run this program, this is what you are going to have. It just prints the numbers 1, 2, 3, 4, 5, and then it breaks out of a while loop. This is while test 0. Since this program does not require you to type anything for input, you can use arrow APL, or you can as well run the program. So it just prints 1, 2, 3, 4, 5. Let's run it again. 1, 2, 3, 4, 5. It is the same output that you will receive in arrow APL. Now let's look at how to control a while loop by user input. We said the loop ends on a certain input. So we'll call it the program while test1.py. We are going to let the user choose when to quit the loop deliberately, which is very practical. So we say a prompt, tell me something, and I will repeat it back to you. We continue to increase the string after a new line, and we say enter quit to end the program. So we create a variable called message, an empty variable. We say while message is not equal to quit, run the loop. Message equal to input prompt, print message. Now this loop is going to keep running whatever somebody types here consistently until the person eventually types quit. If you don't type quit, you cannot get out of the loop. So if you run the program, it's going to look something like this. Tell me something, I'll repeat it back to you. You keep typing anything that is not quit, it will keep repeating it back to you until you eventually type quit and the program quits out of the loop. So here is while test 1 in Visual Studio Code. We'll run it. Tell me something and I'll repeat it back to you. Hello. Hola. Bonjour. Eventually, when you want to leave the program, you should type quit and the program ends. So another way to control a while loop is by using a flag. So we say the loop ends when the flag changes state. It's usually a Boolean value flag. So we call it while test 2. Prompt, tell me something and I'll repeat it back to you. Enter quit to end the program. So we say active, we create a Boolean variable. For instance, we say active equal to true. We can just say while active. This active is the flag now. When the flag changes to false, then we know that we should get out of the loop. So how do we do that? We say message is equal to input prompt. If message equal to quit, we want to change the flag. Active equal to false. Otherwise, print message. So the only time when the flag called active will change to false is when you type quit. And the moment active changes to false, that is when it exits the while loop. So every time it keeps testing. What is active? True. Print the prompt and test the prompt whether the user typed quit. If the user typed quit, change active to false. Otherwise, print the message. If the user did not type quit, you will keep coming back again to test. Is active true or false? True. As long as active is true, it will keep running around the while loop until the user types quit and the flag is changed to false. Then the loop is exited. If you run the program, this is what it's going to look like. So here is while test 2. We'll run it. Tell me something and I'll repeat it back to you. Hey. Tell me something and I'll repeat it back to you. Howdy. Until you eventually type quit. The while loop quits. So let's look at using the break statement to exit a loop. We call this while test 3. Please enter the name of a city you have visited. Enter quit when you are satisfied. So we say while true. You see, we did not even create a Boolean variable. We didn't create anything. We just say while true. So we say city equal to input prompt. Please enter the name of a city you have visited. Enter quit when you are finished. So we say if city equal to quit, just break, get out of the loop. Otherwise, print I love to go to city.title, whatever city was entered. So as long as the user did not type quit, break does not occur. It will keep asking you, please enter the name of a city you have visited, enter quit when you are finished, and if you enter the name of a city, it will say, I'd like to go to that city, until the user eventually types quit and a break takes place. Like we said before, anywhere there is a break in your loop, unconditionally it gets out of a loop. That is the reason why we had the audacity to just say while true, because we know we can use a break to get out of the loop unconditionally. If you run the program, this is what the output looks like. So this is while test 3. We'll run it. Please enter the name of a city you have visited. Enter quit when you have finished. DC. I'd love to go to DC. The program continues. Quit, and the program ends. Now let's look at how to control a while loop by using the continue statement. Like we said before, once the program encounters the word continue in a while loop, it goes back to the beginning of the while loop without executing the rest of the while loop. So we'll call this while test4. We say current number equal to 0. While current number is less than 10, current number plus equal to 1. Increment current number by 1. If current number modulo 2 equal to 0, continue. So let's analyze this. Current number is 0, we increase it to 1. And then we do a modulo operator. Modulo means if we divide current number by 2, is there a remainder? If the remainder is equal to 0, it means there is no remainder. If the modulus is equal to 0, it means there is no remainder. In which case, the number must be an odd number, not an even number. If you divide an even number by 2, you will not get a 0. There will be something here. So every time you meet an even number, continue. Return back to the top of the loop. Increment this by 1 again, and it becomes 2. But anytime you meet an odd number, in which case this part is not true, print the number. So this loop is going to be printing only the odd numbers. 1, 3, 5, 7, 9. If you run the program, that's what it looks like. 1, 3, 5, 7, 9. So here is while test4. Let's run it. Okay. Run it again. And this is the output. Now let's see some much more practical application of what we have been learning. We want to move items from one list to another. So this time around we are working with lists and dictionaries using loops. We call this while list 0.py, a program to move items from one list to another. Let's begin with an example. We have a list of users that needs to be verified, and we also have an empty list to hold the confirmed users. So suppose we create a list and call it unconfirmed users, and we have all these items in the list, 1, 2, 3, 4, 5, 6, and we have another list of confirmed users which is empty. So we want to move items from the list of unconfirmed users to the list of confirmed users using a loop. We will verify each user until there are no more unconfirmed users, which means we will move every item in the unconfirmed users list to the confirmed users list. So while the confirmed users list becomes full, the unconfirmed users list becomes empty. When we say while unconfirmed users, we mean while there is something in the unconfirmed users list. Do something. We say current user equal to unconfirmed users.pop. Remember pop, we are taking an item from unconfirmed users, deleting an item from unconfirmed users, and placing the item in a variable called confirmed user. So we can just print a message to show verifying current user.title. Then we can now append current user to confirmed users list. Finally, we will display all confirmed users by using a loop. For confirmed user in confirmed users, print confirmed user.title. When we run the program, this is what the output looks like. So here we are in while list 0. Since this program doesn't require you to type an input, we can use ARAPL to run it and see the output. Okay, now we are going to use docstring comments to see the various parts of a print so that everything doesn't just come out once. So we have a list here, and we have all these titles right here in the list, items. So we say while unconfirmed users, current user equal to unconfirmed users.pop, and you know that the pop is always removing the last item. When there is nothing inside the call to the pop, nothing within the parentheses, it normally starts by taking the last item. So print verifying user current user.title. First thing was printed, Olorogun. Then it goes back to the loop. There's still something inside it. The next thing was printed, goes back, the next thing was printed, and finally it comes to the first item, which is going to be the last one to be popped out of the list. While it's doing that, it has been appending the items to the formerly empty list of confirmed users. That's what has been happening here. So if we look at the second part of the print, the items in the new list that has just been loaded is displayed for us to see, and that's what we have on this side. Now, still working with lists and dictionaries, let's see how to remove all instances of specific values from a list. This is very practical. We'll call it while list 1. So we have a list of pets: dog, cat, dog, goldfish, cat, rabbit, cat. We want to remove some items from the list, so we have another list called pets to remove: dog, cat. What we want to do is search through the pets list by using the items in pets to remove, and if we find any item in pets to remove inside pets, we are going to remove it. So we have 2 dogs in pets and dog in pets to remove. We will remove the 2 instances of dog. We also have 3 instances of cat, 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 cat in pets, and cat is in the list of pets to remove, so we are going to remove the 3 instances of cats. And what will be left in the list? Only goldfish and rabbit. The best way to do that is to use loops. So create a variable. We just say pets tr to abbreviate pets to remove. For pets tr in pets to remove, while, see, we are now using 2 loops. While pets tr in pets, pets dot remove pets tr, print pets. So let's analyze this. We say for pets tr in pets to remove, the first time it takes dog. While dog is still in the list called pets, remove dog. The first time it removes dog, but it doesn't stop there, so it will now come back to this while loop. While dog is still in pets, the next instance of dog is found. So for every item like dog which you take from this list, you have to go through all the items in this list by using this while loop that is here. So it went, in fact, it's going to go through this list 1, 2, 3, 4, 5, 6, 7 times. This while loop will operate 7 times. because it's going to keep looking for dog. The next time it tests for cat, didn't see cat, and then it goes back again and tested, sees dog again, removes dog. Next time it goes and tested goldfish, nothing to remove. Next time it tested cat, nothing to remove. Next time it tested rabbit, nothing to remove. Next time it tested cat again, nothing to remove. So after going through this loop 1, 2, 3, 4, 5, 6, 7 times, it now goes back to the upper loop. In this case, it's going to take cat. And after taking cat, it comes here again to test. First time it goes through the pets loop, sees dog, it's not there. Goes the second time, it sees cat, it removes cat. Goes the third time, it sees dog, it's not there. Goes the fourth time, it sees goldfish, it's not there. Goes the fifth time, it sees cat, it removes the second cat. It goes the sixth time and sees rabbit, it's not there. And it goes the seventh time and sees cat again, and it removes cat. So by the time we have done this cat and dog, we have finished with this loop. Nothing else to do again. So the upper loop executes twice, while the second loop executes 7 times for each of these. So we have 2 times 7, 14. If you run this program, this is what the output is going to look like. We can use ARAPL to display the output. So here is our while list 1. Open ARAPL and we just modify a part of the code. Okay, so for the purpose of understandability, we are going to do our docstring comments again, so we can separate the print statements. So we created the list and then we printed pets. This is the list of pets. Right. So after going through the loops the way we explained it before, the final list of pets will be just goldfish and rabbit remaining, because we have removed every instance of dog and cat from the original list. So let's see how to fill a dictionary with user input, because in reality, when you create these data structures for a software, you don't know how much data is going to come in. You are going to collect data from users and use it to populate the data structures, the dictionaries, the lists, and so on and so forth. So we call this program whilelist2, a program to fill a dictionary with user input. We create an empty dictionary and call it responses, and then we set a flag to indicate that polling is active. Polling active equal to true. While polling active, prompt for the person's name and response. We say name, impute what is your name. Response. This is another variable now. Which mountain would you like to climb someday? Store the response in a dictionary. So we say dictionary responses. We'll create a key immediately using name, and then the value of the key will be the response. If somebody enters a name, the name will be the key, and the response the person entered will be the value of that particular key. We can still do something else. Print another message. Would you like to let another person respond, yes or no? If the response is equal to no, then you can change the flag to terminate the loop, in which case we say polling equal to false. In that case, polling active will no longer be true. And then we'll print out the results. For name response in response.items. Now this is something new for us. We can actually use 2 items to test. Recall that name is the key, response is the value. For key and value in the dictionary called responses, print name would like to climb response. Now when you run the program, this is what it looks like. We can't use AROAPL because this program actually demands an input from the user. So here is while list 2. We'll run the program. What is your name? What mountain would you like to climb? Would you like to let another person respond? Yes. What is your name? No. So the program quits. Eno would like to climb Everest. Jimmy would like to climb Kilimanjaro. The loop is quitted. So we have come to the end of the class today. The main bibliography still remains the book of Eric Mathis, Python Crash Course. Please like, share, comment and subscribe for more videos. Thank you very much and see you in the next class.